Good people, today we'll be doing the revision of the first principle. First principle is the long format of doing the derivative. So here we need to derive this first principle that they gave us here. So now the shorter format of deriving this, just check our answer here. What are we going to get? It's going to be f prime of here these two is going to times the 3, which is going to give us what 6, and then these two minus 1, it's going to be x, and then plus. Now we have this 13 and this 3. Now from here this x has an exponent which is 1, and that 1 times this 13, it's going to give us 13, and then this one of the exponent of x minus 1, which is 0, and then anything raised to 0, it's 1, so it's going to be 1 times 13. So this is the answer that we are supposed to get when we do our derivative here. Now let's get going. Now first thing, you write the equation of a derivative. It's f of x into lim where h tends to 0 into h where x plus h minus f at x. All these must be all over what? All over h. Now substitute here lim where h tends to 0. So where we see x, we put what? We put to x plus h. So we have 3 into x plus h. All this it's squared, and then plus 13 where we have x plus h, and then minus this minus, then our f at x, which is bracket x 3 sorry x squared, and then plus 13x. All these must be what? Must be all over h, and equals to lim where h tends to 0. Now if we need to get this, let me just do it here. X plus h, and then x plus h. This is gonna give us what? X squared, then plus xh, and then plus xh, and then plus ah squared, and then it's gonna be x squared plus 2xh, and then plus h. I assume guys that you are from grade 12 now, you know how to open your brackets. It's very fundamental thing that you must supposed to know if you're in grade 12. So it's 3 into x squared plus 2xh, and then plus h squared into, now there this times this is going to give us positive 13h x sorry, and then this 13 times the h is going to give us what? 13h. Now times in the bracket here, it's going to be minus 3x squared, then this x times the 13x there, it's going to be 30 minus 13x, and then from here all over h, and then from here we have lim into h approaches 0. We have the like terms there. Let me just first see. We have this, and then we have that cancels each other there. So open my bracket here with this, it's going to be 3x squared, and then this and this is going to give us positive 6 8x, and that it's going to give me what? 3h squared, and then these and these cancel each other, so I'm left with plus 13h, then minus 3x squared, and all this is over what? Is over h. And then equals to, now must also bring my like terms here, the like terms of this and this. I hope you see that one, and then we're left with everything that has h there, which are not like terms. So lim where h approaches 0 uh this and this cancels each other, so I'm left with now 6xh plus 3h squared plus 13h. All this is equals to h, and then we're having lim where h approaches to 0. Now here at the top I have a common factor, the common factor of what? Of h. So if I take h from each one of these, here in the first part I'm going to be left with 6x, and then plus with 3h, and then plus 13h. Oh, the h is no longer there. I've already taken out as a common factor. Sorry guys, there's no h there. And then close the bracket. All this must be over OH, and then h cancels h. Just gonna continue my sum here. So equals to lim where h approaches 0. So I'm having 6x plus 13h, and then plus 13. Now I'm gonna substitute 0 into h. So if you start substituting 0 into h, there is no need of writing what? The lim approaching 0, because it's telling us that it's already approached 0. So it's gonna be 6x plus 13 into 0, and then plus 13, so which is going to be 6x plus 13. This is my derivative of this function that was given to us, which is this one. Now we did our short format of derivative, which was 6x plus 13, which was the answer that we found here, which is 6x plus 13. Guys, if you enjoyed my video, thank you so much guys. Just subscribe to the channel, like the video, and also share the video. Thank you so much, good people.